So Bayesian networks is a method of classification, and it is composed by two things. What are the compounds of Bayesian networks? So the Bayesian networks is composed by what? By a structure. This is the structure, and the conditional probability tables. Yes. So structure plus conditional probability tables, and after that, to create the conditional probability tables, we will consider the relation between the attributes. For example, here, for smoke, for example, we have the parent fire, smoke, fire. For alarm, we have fire and tampering. For alarm, we have tampering and fire. After that, we can derive the probability of a particular combination by the product of the probability of xi if, or given the parents of xi. So the probability of xi given the parents of xi can be extracted from this tables, from the conditional probability tables. Okay. Second questions, classification by backpropagation. Can you give me a method or a technique that classify tuples by backpropagation? Can you give me a technique? So, for example, decision tree can be considered as a classification by backpropagation. Yes or no? No. So backpropagation, for backpropagation, we can code neural networks. So a neural network learning algorithm. Okay. So when we use a neural network, we can talk about topology of a network. Can you explain me what's the meaning of a topology? Topology of a network. The structure, yes. That means what? No. That means topology of a network, that means, yes, how many layers? Yes, the different layers, and after that, how many hidden layers, how many neurons in hidden layers, how many neurons, the number of neurons in the input layer, the number of neurons in the output layers, etc. Okay. After that, during the learning phase, the network learns by adjusting the weights. What are weights? What's the weights? What is a weight? So here, this is a weight. We will multiply this value by this weight and this value by this weight, and the sum here, we will use the sum, and after that we will apply an activation function. So how we can make learning from input to output? We will calculate the output giving an input vector x. We will calculate the output y, and after that we will see if y is equal the real class. So if y is the equal real class, it's okay. If y is not equal, is different from the real class, in this case we have to adjust all this weight. We have to adjust all this weight to minimize the error between the predicted class and the real class. So the adjusting of all this weight will be from the output vector to the input vector. For this reason, we talk about backpropagation. Why we say that it is a backpropagation method? Because the adjusting of different ways, yes, will be from the output vector to the input vector. Okay, this is backpropagation. Support vector machines. So, can you explain me how the support vector machines classify the data? How support vector machines classify data? So if we have a nonlinear problem, yes, linear function, it serves the linear optimal separating hyperplane. So yes, to separate data. And it uses a nonlinear mapping to transform the original training data into a higher dimension. So support vector machines transforms the original training data into a higher machines. What are the support vectors? Support vectors. What represent support vectors? Yes. So support vectors are essential training tuples that defines the margin between the classes. So for example, in this example, all this training tuples represents support vectors. And we want to get the maximum of the margin between the first class and the second one. So how we can perform classification using frequent patterns? What's the meaning of classification by using frequent patterns? Classification by using frequent patterns. So classification by using frequent patterns, that means associative classification. That means we will mine data to find strong associations between frequent patterns and class labels. So the association rules are in the form P1 and P2 and PL implies A class equals C with a confidence and a support. Okay, so can you give me what is the difference between decision trees and associative classification? What is the difference between decision trees and associative classifications? Yes. Do you hear me? But here our model is the association rules. So in the associative classification, we want to create a model also, and the model will be presented by all the association rules in the form of P1 and P2 and PL implies A class equals C, for example. Okay? But what is the difference? The difference is here between now. So the difference, when we use associative classification, we can overcome some constraints introduced by decision trees. What is this constraint? This constraints. So decision trees considers only one attribute at a time. Considers only one attribute at a time. But associative classifications can consider all the attributes at the same time. It is clear the difference between associative classification and decision trees? Okay, when we build a decision tree, at a time we have to select only one attribute. Yes or no, Ahmed? But here, when we use associative classification, we can use all the attributes together at the same time. And associative classification has been found to be often more accurate than some traditional classification methods such as C4.5. Lazy learners. Can you hear me? Can you hear me? Okay, lazy learners. So what's the meaning of lazy learners? What is the difference between lazy learner there is a Okay, so training data is the model. Very good. Yes, so lazy learning simply stores training data and waits until it's given a test tuple, and eager learning, given a set of training tuples, constructs a classification model before receiving new data to classify. So when we use lazy learners, what is the advantage of lazy learners or lazy learning? What is the advantage? Yes. So when we use lazy learning, we save the time in the training, because the training here we will not perform a training to construct a model. But yes, but the disadvantage. The disadvantage of lazy learning. So lazy learning has more time in predicting. More time in predicting. We have to calculate the distance between our tuple with all the tuples in our database. It is clear? So, lazy learner instance-based methods store training examples and delay the processing until a new instance must be classified. For this reason, it is called lazy. So, typical approaches. We can use k-nearest neighbor approach, or locally weighted regression, case-based reasoning, etc. So there are many approaches for lazy learning. So the KNN. So KNN can be used also for real valued prediction for a given unknown tuple. It returns the mean values of the k nearest neighbors. So if our class is a discrete or nominal class, that means the value of our class, we have 3, 4, 5 values. In this case, we will use the majority voting. But if our class is a real value, that means we want to predict a real value, not a class like A, B, C. In this case, KNN returns the mean values of the k nearest neighbors. It is clear? Okay, let's move now to other classification methods. So there are other classification methods like genetic algorithms. So genetic algorithms is based on an analogy to biological evolution, and to make genetic algorithm, an initial population is created consisting of randomly generated rules, and each rule is represented by a string of bits. For example, this is an example of a rule. If A1 and not A2, then C2 can be encoded as 100. So based on the notion of survival of the fittest, a new population is formed to consist of the fittest rules and other offspring. So there is a detail of this genetic algorithms. For you, keep in the mind that genetic algorithms is a technique for classification, and it is based on an analogy to biological evolution. Other classification methods is a fuzzy set approaches. Fuzzy. Why we said that it is a fuzzy? Fuzzy logic uses truth values between 0 and 1 to represent the degree of membership. So here we talk about degree of membership, such as in a fuzzy membership graph. So attribute values are converted to fuzzy values. For example, income X is assigned a fuzzy membership value to each of the discrete categorized low, medium, high. For example, here this value belongs to medium income and also belongs to high income. For medium income with fuzzy value 0.15 and for high income with fuzzy value 0.96. So fuzzy membership values do not have to sum to 1. Each applicable rule contributes a vote for membership in the categories, and typically the truth values for each predicted category are summed, and these sums are combined. Any questions? Let's move now to additional topics regarding classification. The first one for multi-class classification. So what's the meaning of multi-class classification? Multi-class classification, that means classification involving more than two classes. More than two classes. That means in the class attribute, we can find more than two possibilities. So there are two methods to handle the problem of multi-class classification. The first method is one versus all. Learn a classifier one at a time. So given M classes, train M classifiers, one for each class. It is clear? One versus all. To classify a tuple X, the set of classifiers vote as an ensemble. The second method is all versus all. We will learn a classifier for each pair of classes, and given M classes, we will construct M multiplied by M minus 1 divided by 2 binary classifiers. And a classifier is trained using tuples of the two classes, and to classify a tuple X, each classifier votes and X is assigned to the class with maximal vote. So keep in the mind that for multi-class classification, that means the class has more than two possibilities, and there are two methods to make classification. The first one is one versus all. The second one is all versus all. So if we compare these methods, all versus all tends to be superior to one versus all. But the problem, binary classifier is sensitive to errors, and errors affect vote count. Any questions about multi-class classification? Do you hear me? Okay. Let's move now to semi-supervised classification. Why semi-supervised classification? We will use labeled plus unlabeled. Labeled plus unlabeled data to build a classifier. And here there are many possibilities of, or many kinds of semi-supervised classification. The self-training, that means we will build a classifier using the labeled data, and after that we will use it to label the unlabeled data, and those with the most confident label prediction are added to the set of labeled data. We will repeat the above process, and for this reason we talk about self-training. The advantage is easy to understand, but the disadvantage may reinforce errors. This is the first manner to make semi-supervised classification. The second manner is co-training. So what is the meaning of co-training? We will use 2 or more classifiers to teach each other. How we can do it? So each learner uses a mutually independent set of features of each tuple to train a good classifier, say F1 for example. Then F1 and F2 are used to predict the class label for unlabeled data X. Each teach each other, so the tuple having the most confident prediction from F1 is added to the set of labeled data for F2 and vice versa. So there are also other methods like joint probability distribution of features and labels. Any questions about semi-supervised classification? Active learning. Why active? Why we said that it is active learning? Because here we have a human. So class labels are expensive to obtain. Active learner query human for labels, and the pool-based approach uses a pool of unlabeled data. For example, if we have L is a small subset of D is labeled, and U is a pool of unlabeled data in D, we use a query function to carefully select one or more tuples from U and request labels from an oracle, a human annotator. So the human annotator here give us the labels. For this reason we said that it is an active learning. The newly labeled samples are added to L. L is the small subset of D with labeled data, and learn a model. So the goal is to achieve high accuracy using as few labeled data as possible. Evaluated using learning curves, accuracy as a function of the number of instances queried. The number of tuples to be queried should be small. There are many research issues how to choose the data tuples to be queried. Uncertainty sampling, choose the least certain ones, reduce version space, the subset of hypothesis, consistent W, the training data, reduce expected entropy over U, find the greatest reduction in the total number of incorrect predictions, etc. Yes, U has the majority, and L is a small subset. So the majority of data here is unlabeled data, and L is a small subset of D, and L represents the labeled data. After that, here the idea is to select a few tuples from U and request labels from a human annotator. This is the idea. For this reason, we said that it is active. And our goal is to achieve high accuracy by using a few labeled data as possible. It is clear? Okay. Transfer learning, conceptual framework. So transfer learning, that means extract knowledge from one or more source tasks and apply the knowledge to a target task. Traditional learning builds a new classifier for each new task, but transfer learning builds new classifier by applying existing knowledge learned from source tasks. So this is, in this schema, this is the traditional learning framework. And in the traditional learning, we will build a new classifier for each new task. New classifier for each new task. But for transfer learning, we will use or we will build a new classifier by applying existing knowledge learned from source tasks. So the new classifier here will be built by applying existing knowledge. We will apply existing knowledge learned from source tasks. This is the summary of our chapter. So in this chapter we discussed effective and advanced classification methods, the Bayesian-Belief network, the backpropagation neural networks, the support vector machines, the pattern-based classification or associative classifications, and other classification methods like lazy learners, for example, KNN, genetic algorithms, row set and fuzzy set approaches. Additional topics are discussed also in this chapter. The multi-class classification, the semi-supervised classification, and in the semi-supervised classification we discussed the self-training and the co-training, the active learning and the transfer learning. Any questions about this chapter? I don't know. It depends of our meeting with the coordinator. But normally in the study guide we will يعني من المفروض انه في study guide بيقول اذا في mathematical equation or no. هو في الأغلب ما فيه، بس الأمور إلى حد الحين ما هي متأكدة، هنأكدها في الستدي جايد إن شاء الله.
شكرا يا دكتور، يعطيك العافية.
Other questions؟ طيب أنا دقيقة عشان أخذ ال participant list. الله يعافيك، شكرا جزيلا.
دكتور عندي سؤال على الاكيورسي حق الكلاسيفيكيشن تقريبا. اي نعم
تفضل.
احنا بالعاده ناخذ الاكيورسي اذا كان عندي 5 رولز.
وعليكم السلام ورحمه الله وبركاته.
الاسوشيشن الموجوده في الموديل، انا اطلع الاكيورسي من الاساينمنت ولا من عدد
حق الاساينمنت
او من عدد الريكورد؟
ايه تفضل.
يعني مثلا انا اقسم على مثلا لو زي